In this example, we're looking at how many arrangements or how many words are possible from the word taste. Now, for the sake of clarity, we'll assume that words don't necessarily have to be words that you find in the English dictionary. They're just rearrangements of the letters. One of the things we need to be very careful of in this example is that one of the letters, T, is repeated. So we're considering the number of permutations from a group of 5 letters where there is a repeat of the letter T. So let's consider one possibility, which is TTASE. So that's one possible word. Now we've put the T's in different colours because what we'll do is we'll swap the position of those T's, but you can see the end result is exactly the same word. So we've got TTASE again. So even though we've swapped the T's, the end result is exactly the same. So we can't count it as a different arrangement. It's just the same arrangement. So to determine a process to calculate the number of words in this case, let's look at a simple example first. What we'll do is we'll consider all the 3-letter words we can make from the word all. A good idea would be to pause here, write down all your possible 3-letter words that you can get from the letters A, L, L, and see if we agree. So here is our list, and what we've done is we've indicated the 2 L's in different colours, just to show what would happen if we swap them over. Let's have a look at the 2 cases on the left-hand side where we've got the word all with 1 L in brown and 1 L in green. By swapping the L's over, we still end up with exactly the same word. So instead of getting 3 factorial words, which is 6, we've actually only got 3 unique words. So a way to calculate this would be to say 6 divided by 2, and of course that comes to 3. So let's have a look at another example. This time we've got 4 letters, but we've got a repeat of the letter A. In fact, it occurs 3 times out of the 4. So if we just listed all the possibilities using different colours, we can see that we've got 4 factorial, which is 24. But by rearranging the A's, they end up being the same word. We can see in our table that there are 4 columns of the same word repeated 6 times. So you can see that the A's have been rearranged because that's what we've got with the different coloured A's. So overall what we have is 24 possibilities. But because within each column we've got a repeat of the same word, we divide 24 by 6. Of course 24 divided by 6 just comes up with 4. So we have 4 unique words. In terms of factorial notation, 4 factorial gives us all the rearrangements of 4 characters, in this case the 4 letters A, and B. But we have to divide that by 3 factorial because within that 24 there is repeats. In this case we can see from the columns 3 factorial, which gives us 6 repeats of the same word. So the way to calculate the number of words that can occur, what we do is we still look at the number of characters, in this case 4, and we have 4 factorial. But we divide it by the number of times a certain letter may be repeated. So going back to our original example, we have a 5-letter word which has the letter T written down twice. So the number of words that we could have is 5 factorial because there are 5 characters being shown, but we have to divide it by 2 factorial because one of the letters, in this case T, is repeated. And 5 factorial divided by 2 factorial comes to 60. Let's have a look at another example where there's not just one letter that's written down multiple times, but in this case 2. And we want to work out how many 4-letter words we can make from the word yo-yo. Let's first of all actually list them so we can see what would occur if we write down all the characters in different ways. We can see from our list that we've got 6 possibilities. Now the way to actually calculate this, rather than write down the lists all the time, would be to say that because we've got 4 letters, the first thing we'll do is we've got 4 factorial possible arrangements. But we have to consider that the letter Y is written down twice, so we have to divide 4 factorial by 2 factorial, and then do that again. In other words, divide by 2 factorial again because the letter O is repeated. Now when we do that in our calculation, we can see that 4 factorial is 24. And if we divide it by 2 factorial, that's like dividing by 4. So 24 divided by 4 is 6. So a general case that will help us do this calculation in a variety of situations would be to consider if we've got n objects and we're trying to rearrange them, but one of the elements occurs multiple times, in this case p times, and if another element occurs q times, etc., the way to determine the total number of ways is to go n factorial and then divide by the product of p factorial q factorial multiplied by however many times any other characters are repeated.